try this again. I got interrupted earlier. All right, so this is not a very fun worksheet. It's kind of rough. It's got 4 terms here on the first one. That's factoring by grouping. I've got all the forms you should probably need along the top. I'm going to do a couple of them because it's kind of rough. So I know this first one had 4 terms, so I'm going to cover up the back and focus on the front. And I can pull x squared because I see an x squared in the second one. I know x cubed has x squared from both pieces. And when I do that, I'll be left with x minus 5. Wish I had a darker pen, but in my absence, it appears somebody stole all my pens. And I don't see a darker pen. So what I got is this blue one. And it's just going to have to do. Now, I want to make x minus 5 a factor again. So I look at the last 2 terms, and what I'm going to do is I'm going to pull the negative. Pull a negative 1. That'll give me minus 1, and then I'll have x minus 5 as a factor. So now I'm down from 4 terms to 2 terms, both of which contain x minus 5, and the crap left over is x squared minus 1. And the whole quantity, by the way, is still equal to 0. I just forgot to write it. Now you are supposed to factor completely. This x squared minus 1 is this pattern up here, a squared minus b squared. A would be the first thing you see that is squared, so a is x. And b is the second thing that you see that is squared. It turns out that 1 squared is still 1, so a is x and b is 1. So x squared minus 1 is x minus 1 times x plus 1, all equal to 0. Now I use the cover-up technique. X minus 5 is 0, x minus 1 is 0, and x plus 1 is 0. And I just solve those 3 easy equations. So x is 5, x is 1, or lastly, x is negative 1. So that one wasn't too bad. All right. Number 3, you got a hunch 3 is going to be a rough little problem. First off, you have to factor the trinomial as a product of 2 binomials. To create an x to the 6, you need an x cubed and an x cubed. Now you need factors of 27 that add to 26, which thankfully is 27 and 1. We do minus 27 plus 1. Whole quantity is still equal to 0. All right. And now we're going to keep factoring. It says factor completely. It's what it says up top. You see that? Factor completely. And I was looking at x cubed minus 27. X cubed minus 27 is an a cubed minus b cubed pattern, which factors as a minus b times a squared plus ab plus b squared. A is going to be x because I cube an x to become x cubed, and b is going to be 3 because I cube a 3 to become 27. So this is going to be x minus 3 times x squared because I square a, plus because there's a plus. 3 times x is 3x, and then I square the 3, b was 3, plus 9, and I got to bring this factor down. X cubed plus 1, all equal to 0. And now she is completely factored, and now I have to solve, and it says find all solutions, every blasted one of them, real or imaginary. Notice it says find all. So the first one's easy. X minus 3 is 0, means x is 3. There's 1. I'm going to do this one next because it's the second easiest one up there. X cubed is x cubed plus 1 is 0. This actually isn't a hard problem. X cubed is negative 1. The opposite of cubing is cubic rooting. And my pen just went out. Perfect. It's going to be one of those days. I wonder if anybody left a pencil or something here. Try another one. All right. I think I got something that works. Kinda. Still doesn't work. all the things to be stopped by, it's a pencil. Try this one. Anyways, the cubic root of x cubed, I know that's hard to see, is equal to the cubic root of a negative 1. So to become a negative 1, you do negative 1 times negative 1 times negative 1, so x is negative 1. So I've found two solutions. By the way, this one actually happens 3 times. It was x cubed. It actually has a multiplicity of 3. This one had a single x, multiplicity is 1. Turns out I've actually found 4 of 6 answers. That's for another lesson. Don't let that throw you off. But maybe me talking about it will make more sense that day. Last one is this bad boy. X squared plus 3x plus 9 is equal to 0. That's not going to factor. It's going to be imaginary. Remember that from Tuesday? These are your imaginary solutions. So we hit it with a quadratic formula, which is given to you. Opposite b would be negative 3 plus or minus square root of b squared minus 4 times a, which is 1. It's in front of x squared, times c, which is 9. All sitting pretty over twice a, twice a 1. Inside that radical is 9 minus 36, which should be negative 27. Both pieces sitting over at 2. And what I'm thinking about in my head, and I'll write it on paper, is this root of negative 27. That is equivalent to the imaginary root of 9 times 3. Because it's imaginary, and 27 is 9 times 3, which is equivalent to 3i root 3. So x is negative 3 halves plus or minus 3i root 3 over 2. And there's my last two answers. So 2 answers here. There were 3 here. That makes 5. 1 here. That makes 6. That's fundamental theorem of algebra. All right. I'll do one more of these for you, but you're going to have to do some of it. I'll do another factoring by grouping one, number 6. That's x to the 9th, which is 9 solutions. 9 solutions. But a lot of them are going to be repeated answers. So I see 4 terms, so I do factoring by grouping. I can pull x to the 6th from the leading thing. That'll leave me with x cubed minus 1. And to make this factor repeat, I pull a negative 1 from x cubed plus 1. So here's what I have. I have x cubed minus 1, the common factor, and x to the 6th minus 1, which is the crap left over. X cubed minus 1 will factor, but x to the 6th minus 1 still factors as well. So I'm going to factor it. This is actually an a squared minus a b squared pattern, which you can look at above top, which is a plus b times a minus b. To create an x to the 6th, I need an x cubed. And to create a 1, I need a 1 and a negative 1. One's negative, one's positive. Whole quantity equal to 0. All right. Now, I am supposed to completely factor. I'm very happy that this happened twice because I really only have to do it once and I just write it back down. This is an a cubed minus b cubed pattern. It's a cubed minus b cubed. X cubed minus 1 is x minus 1. I square a, x squared, plus 1 times x is x, square the 1, plus 1. And it happened here that way, so it's going to happen again here that way. X minus 1, x squared plus x plus 1. And then I've got this factor x cubed plus 1. Whole quantity equal to 0. Now, these two factors are pretty easy to do. You know, x minus 1 is 0, x is 1. That's an easy one too. We did it earlier. X cubed plus 1 is 0. X cubed is negative 1, so x is negative 1 because a negative 1 times a negative 1 times a negative 1 is negative 1 still. And then I'll have, so there's one answer here, 3 there. That makes 4 of 9. And, or maybe 5, I can't count, I don't know. There's answers here and here. Oh, that guy happened twice, didn't he? So this has a multiplicity of 2. It happened twice. This one has a multiplicity of 3. That's 5 answers of 9 total. So I still got 4 to go, which happened here and here. And they're just done with the quadratic formula. X is opposite b, so it would be -1 plus or minus square root of 1 squared minus 4 times a, which is 1, times c, which is 1. Both sitting over twice a, and again a is 1. Inside my radical, I have 1 minus 4, which is -3. Both pieces sitting over at 2. -3 is imaginary, so I'm -1/2 plus or minus the imaginary root of 3/2. And there should be 4 answers there because there was 2 here and 2 here on the repeated factor. So that makes 9 solutions. All right, backside. I'm going to do 2 of these. Divide the following polynomials by the given divisor using long division. If the remainder is not 0, write the remainder over the divisor. It does say use long division. I'm going to do number 10. My vinculum is going to contain 9r squared minus 27r plus 14. And my divisor goes on the outside, 3r minus 2. I'm going to multiply 3r by 3r to become 9r squared. And 3r times -2 is -6r. I'm going to do addition, so I'm going to change the signs, because addition of the opposite is the same as subtraction. -21r when I add, bring down to 14. To turn a 3r into a -21, I multiply by a -7, and that's going to give me -21r plus 14, and then I'm going to add the opposites, and bam, remainder of 0. Turns out 3r minus 2 was a factor because the quotient didn't have a remainder. All right, now I'm going to do 12. Completely factor f of x is 15x to the fourth plus x cubed minus 52x squared plus 20x plus 16. And by the way, I got up at 5 a.m. to make this sheet. So, the kids don't do work, they complain. Teachers don't do stuff at home, whatever. I work my little rear end off for you. Somebody's coming to bug me. What's up, Luke? Oh, yeah. You need a lot of autographs, don't you? It's only 3. It's horrible. Let's see. I'm pretty sure every time this week was myself. That day was myself. 11:10 would have been me. 11:18 was also me. Thank you, sir. Anyways, where was I? Number 12. So you're supposed to completely factor that polynomial given, I don't know why the word a there is there, given known factors of x plus 2 and x minus 1 by using synthetic division. So this was a lesson that was taught Thursday. If a known factor is x plus 2, what we do is we say we equal 0, so x is -2. And we do the same thing here, and we get that x is 1. Those are the actual x values that I use in synthetic division. You draw an upside down 2-story vinculum, and you load it with the coefficients. So 15, 1, -52, 20, and 16. And you do that whole drop, multiply, and add thing, DMA, drop, multiply, and add. I'm going to take the smaller one out first. So I drop the 15, I multiply, and I get 15. I add, and I get 16. I multiply, and I get 16. I add, and I get -36. Seems legit. I multiply and I get -36. I add and I get -16. I multiply and I get -16, and bam, I got a 0. Because I have a remainder of 0, I can repeat the synthetic division process. I have reduced or factored out a polynomial, and now I'm going to synthetically divide out the -2, which I came up with earlier. Drop, multiply, add, multiply, add, multiply, and add. So here's what's happened. I have factored out x plus 2, and x minus 1. And I have reduced to, and remember how this goes, remainder, constant x squared. I have reduced to 15x squared minus 14x minus 8. And now I'm going to try and factor the reduced polynomial. I'm just going plain old guess and check factoring. I'm going to guess that to make a 15x squared, I need a 5 and a 3. If I'm wrong, I'm wrong. I'll mark it out and I'll try again. I'm going to guess an 8 would be a 4 and a 2. And I happen to be right. If I put the 4 here and I put the 2 there. Because the outside makes 20x and the inside makes 6x. And the goal is to get to negative 14. So make the 20 negative, make the 6 positive, bam, done. So now I have it completely factored. Completely factored. I have the existing factors, the x plus 2 and the x minus 1, and I have the new factors that I found with guess and check of 5x plus 2 and 3x minus 4. And welcome to what is technically classified as intermediate algebra. I know a lot of kids say this is hard, this is rough. This is intermediate algebra. It is not advanced algebra. It is not hard algebra. It's classified as intermediate, which basically just means average. So get your crap together, wake up, and figure it out, because it ain't hard yet. It doesn't even get that hard in this class. It's just intermediate algebra.